Well, good morning. Yeah, good morning, everyone. Salah Sukkarieh, and Dylan's asked me to kind of present the work that we've been doing in the vegetable industry and kind of giving a wrap up of the activity that's been happening across two programs that have been funded by Hort Innovation, so VG1503 and VG15059. What I've done is I've broken it up and kind of trying to structure it in the way we've been thinking about how the program's been working in the activity space. Sorry, my voice has been going lots of talking this week. On the left-hand side is what we call the TRL, so technology readiness level, from 0, which is just a bunch of geeks sitting in a lab scratching their head thinking, what would I like to do next, all the way through to number 9, which is there's a product that's making money in some form. And the projects are spread between TRL 0 all the way through to about TRL 7 in that activity. You can see the two programs there and how they feed into each other. The first one is really about building a science platform that allows us to do things such as check out new sensors, do some data analytics, build up some science, and understand what might be of use from a push technology perspective. And in 15059, what we're trying to do is when we feel comfortable with some of that technology, we feed it out into the second platform and put it onto operational farms, and then get some feedback from growers and then kind of work backwards into the research again. So that's how they're related to each other. And the whole idea is that you de-risk the technology as you're going through until you get to a point where you can then throw the stuff onto a farm and have it in an operational context and potentially in a commercial context as well. So that's the kind of flow through of the two different projects. And what I'm going to do is just kind of give you a summary of each project and where we're at the moment now. The first one is with Ladybird. It's a platform that we built about 5 years ago, and we were given enough funding to be able to sit down and relook at what robotics would look like on a farm. So we had two objectives. One was to either sit down and say, should we look at a tractor, an automated tractor, or should we build something from scratch? And we went down the second option, mainly because there was a lot of technology that was coming off the shelf that we could start to use in the transport industry, in the solar industry, and so forth. So they're solar electric platforms, individual drive modules, which means we can adjust them for different row widths. It runs for about 7 to 10 hours on batteries alone, and on a nice day like today in Brisbane, you could probably get 12 to 14 hours with the energy coming in through the solar panels as well. Underneath there's a large collection of sensors, hyperspectral, infrared, vision, laser units, and we collect all that data, and then we start playing with some data analytics and started to work out new algorithms. And then whatever works into both the sensors as well as the algorithms goes into the next platform. This will be a typical day of operation for us on our university farm. We'll grow our own crops. So as engineers, we've learned a lot about planting seeds and kind of going from there. So it's been a lot of fun. But as you see here, what's happening is as Ladybird goes up and down, the team of researchers go behind and we start taking some measurements of the individual plants, some more accurate measurements. So what we're trying to do there is calibrate the information that comes from the sensors on the robot with what we're measuring as well. And that gives us some vital information to be able to close the loop on that process. As an example, what we can do now with some of the algorithms is be able to build up crop yield estimates. So those blue circles or the blue ellipses that you see around the plant, so this is on a lettuce plant, is trying to measure what yield would look like on each individual plant as we're going through. And we can do quite well, so you can see this linear, almost a linear plot through there. On one axis is what we've observed or what we've measured, on the x-axis is what we've predicted. And what it's really showing you is that we're getting better and better at algorithms at being able to say, I've sensed an individual plant, what's its yield at this point? We've measured it and we've shown a very close correlation between the two. So in other words, now what we're getting down the path is this automated yield estimation. What's more important is that as you go over it each day, you can start to see the change in the yield and you can start to do prediction and growth parameters. And that becomes quite interesting because then we can start to say, well, what should I do next to this individual plant in order to reduce, say, crop variability across the whole paddock. So that's the kind of trajectory that we're going on. So that's one thing that we've been doing, but there's a whole bunch of other aspects around decision making that I'll talk about a little bit later as well. So that's on that program. So what we do is we kind of grab all this data and algorithms and we feed it through. And then we put it onto the next platform, which is Ripper. Again, solar electric. This one now on batteries alone runs for about 12, 13 hours. On a nice day, we can get 24 hours. In fact, and we've done day-night operations. We've done continuous operations throughout a day where we haven't touched the robot and it's just gone out there. The sensors underneath are less sophisticated sensors compared to Ladybird because what we're trying to do now is how do we reduce the cost of the platform and the sensors so that it could actually work on a farm and be used by a farmer. There are two rippers at the moment now, one that we use more on our operational farm, the second one that we take on our field trips. There's been some updates. So at the moment now we've done 15 on-farm trials, and there's about another 4 going on this year between Queensland, New South Wales, Victoria and Tasmania. We kind of keep cycling through, testing out the robot on different farms. The second bot has some higher torque motors and some mud scrapers because we were trying to test it out on what would happen on more wet, cliggy soil. And the other real key thing is that the machine learning algorithms that we have on board now, we don't need to go back home and then start to run the data through the algorithms. We can actually do them on the farm now. So we've been able to go to new farms with new crops, run the robot up and down the rows, and after 2 hours, the robot starts to build up models of that individual plant, whether it's lettuce or broccoli or baby leaf or whatever it might be. So that's kind of advancing the technology to that point now. So a typical operation will look like this. I'll probably speak. Oh, okay, that wasn't a good thing. Sorry. So this will be just a breakdown of some of the things that it can do. So it goes up and down the rows autonomously. We can detect individual plants in real time autonomously using machine learning algorithms. From that, we can get individual yield estimation results for each individual plant. And as I was saying before, if you have this robot going up and down all day continuously, then you start to get plant metrics in terms of how they change, so the health metrics. You can detect individual plants from individual crops, and hence also weeds or whatever it might be from there. So we started to look at things such as mechanical weeding, and what does that mean? Just to disturb some weeds and not use any fertilizer use, any herbicide use. But we also have a little sprayer as well that comes along and can detect each individual plant and just spray the right number of mils that you want per individual plant, whether that's herbicide or pesticide or fertilizer, as an example. And there's also a soil sampling system, so we can measure water conductivity at any particular plant location. So what you've got is this rolling smartphone that has all these apps on it, and you plug different mechanical tools on it and starts to collect all this information, and you can start to build up that knowledge as you're going up and down the rows. One of the recent trials that we looked at was about foreign object detection and foreign object removal. This is just a Ryobi vacuum cleaner that we got off Bunnings, and we plugged it underneath, but we attached it to the machine learning algorithms. And so now whenever it detects a foreign object in whatever form, then what its objective is to just suck it up and take it on from there. So it's really just kind of pushing different types of aspects on the robot, testing it with the farmers, seeing whether the farmers like it or not, whatever it might be, and if they do, then pushing it out even further from there. The other aspect also is the user interface. So what does the farmer see? So this robot's going up and down 24 hours a day, 7 days a week, and we're able to look at different types of graphical measurements that will allow your farmer to understand the different growth patterns of the different rows on the different paddocks, and be able to click on an individual plant and just look at the different spectral responses if they want to. So that's part of the aspects that we're looking at well. So what you see is a soil map measurement on the right-hand side. On the left-hand side, you'll see yield estimation. So the darker the plot, the individual yields, and as well as you will see some red bits there where we have predicted that the plant is actually, we don't think is growing at the right pace. Remember how I mentioned before, you can look at individual yield estimates and you can start to see plant growth. If one individual plant is not growing the same as the others on the row, we can highlight that as well. What's nice about a ground robot versus, say, an air robot is you can actually start to do something. You can spray, you can remove in whatever form. So the next things, what are we looking at now, is you'll see a whole bunch of different metrics. That's on the left. These are the standard metrics that you'll find in the literature. So this is using spectral sensing. And what we're doing is that in real time, you can come along and start to pick up all of these metrics, because some farmers say they use certain metrics and other farmers say they'll use different metrics. And what we're doing here is we're just plotting them all out. What's of interest from a machine learning perspective is that we're able to figure out what the relationship is between different metrics, and be able to understand things such as plant health down to the individual plant itself. And so where the current research is going at the moment now is how do we use that type of information to predict the growth model of an individual plant and make decisions about what we should do to that individual plant. When we did the economic analysis, one of the things that we looked at was reducing crop variability. And we can start to look at that by looking at plant growth and spraying individual plants to modify their growth potential so that you try to minimize that growth predictability. So this is the last slide, and really it's just showing you where we are with the different elements. That line that you see at the bottom there is really where the projects end. That's, we're meant to de-risk the technology all the way up until that line. And the whole objective then is you take that line and then feed it into either a spin out, or you license it, or you give it to an OEM. So you'll see that some of the earlier activities, so Ripper, the spray unit, the mechanical weeder, The weed detection element and the soil mapping, that's already at that point to go out. The parts that we're looking at now is yield and variability mapping, as well as foreign object detection. We're starting to look now at health and pest, as well as individual fertilizer decision making, and you'll see over the next, we have 2 more years on the project, so you'll see over the next year that dropping down to that TRL7, and we're always listening to farmers to try and figure out what the next bit of research is as well. So, thank you.